Hi, in this video, we're going to solve a advanced level problem which appeared in 2019. The problem came in the chapter called matrix, okay, and determinant. Let's go ahead. So first understand the problem. So here the matrix M and the corresponding adjoint of the matrix M is given. M and ADG of M is provided. And the M has some two unknown parameters, right? A and B. Now we have to check that which options are correct, right? So first of all, it is obvious that we need to calculate the value of A and B. And we have to test the remaining cases, right? Let's go ahead and solve the problem. So first we consider the matrix M, and also right here what we need to calculate the adjoint of M. What is adjoint? It is a transpose of a cofactor matrix. So let's go ahead and consider the cofactor matrix as Cij. Okay. Now Cij means that C11 is the cofactors of M11. M11 is the element of the matrix M. Now let's proceed, right? So what is C11? To calculate the C11, we have to eliminate, right, the first row, first column, and then the remaining minors, right, that is 2, 3, B1, that's 2 by 2 matrix will be the minor of that matrix, the minor of that element 0, okay, or the minor of the element M11. Now, we need to find the cofactor. So that's why we need to multiply the minor by minus 1 whole to the power I plus j. Here I is 1, j is 1. So that's it. So if I calculate, we get it as 2 minus 3b. Let's go ahead and try to eliminate the first row, second column to obtain, right, the minors. Now here the minors for M22, M12, that is 1 is equal to, right, 1331, right? So therefore we get it as 8. And if I eliminate, right, the first row and third column, we get C13. And if we calculate the determinant by a normal approach, we get it as B minus 6. So these steps are very easy. Now let's go ahead and calculate C21, right? So second row, first column, we eliminate it. We get it as 1A B1. If we calculate, we get it as AB minus 1. If we proceed in the similar way by eliminating that one row and one corresponding column, ith row, ith column and all the stuff, we'll able to obtain the cofactor matrix or all the entries of the cofactor matrix, right? So let's go ahead and see that, right? So we obtain step by step all the cofactor matrices, right? So here obtain that we obtain that C11, C12, C13 and so on, right? So therefore the collection of all, right, will give us the adjoint of the matrix if I take the transpose. So therefore adjoint of M is equal to that C11, C12, C13 and so on and the transpose matrix. So therefore by normal calculation from the matrix M we obtain the adjoint of M. So let's go ahead and take that adjoint of matrix. Now this is the adjoint of M. Now obviously notice that the adjoint of the matrix M is also provided in the problem. So now we calculate the adjoint M from the matrix M and one adjoint matrix is already provided. So therefore element wise we can compare these two matrices because these two matrices must be equal. So if I compare element wise, right, so therefore we get it as 2 minus 3b is minus 1, ab minus 1 is equal to 1, 3 minus 2a is minus 1, 8 is equal, forget it, minus 3a is equal to minus 6 and b equal to 2, b minus 6 equal to minus 5. So we obtain 4 for 6 different relation. Now obtain that from 5 it is obvious a equal to 2 and from 6 b is equal to, right, we can easily calculate that as 1. So ab is obtained. But we have to test each and every cases that 1 to 4, right? So see that if I substitute that value a equal to 2 and b equal to 1 in all the equation from 1 to 4, all the equation are satisfied. And this is a very crucial test because if we don't test that, right, we don't know that, right, the system is consistent or non-consistent, right? But as it is satisfied, so the system is consistent. That means, right, we can get the given adjoint M can be the adjoint of the given matrix. So this is, we proved it here, right? So now our required values of A is 2, B is 1. So therefore we can find that A plus B is equal to obviously 3, as trivial as it is. So therefore in this problem option D is definitely the correct option. So one option we tested. That's it. Now also notice that we already get that A value and B value. So therefore we can put that A equal to 2 and B equal to 1 in the matrix M, right? And we get the proper matrix where the no unknown will be there. So let's go ahead. So here we get the matrix M. So now we have to test the correctness or truthfulness of the option A, B and C. That is the remaining part. Let's go ahead. So now, first we go ahead and notice that, right, that determinant of adjoint M square. So basically we are trying to test the option A. So here, determinant of adjoint M whole square can be written as determinant of adjoint M and whole square. This is the property. And now, determinant of adjoint M. We know that, right, that determinant of adjoint M can be calculated by expanding that adjoint M matrix with respect to the first row. If I expand it, right, determinant of adjoint M will be minus 1 multiplied by minus 6 into minus 1 inside the bracket, 2 into 3 with a minus sign, minus 1 into 8 into minus 1, 2 into minus 5. That's a very basic step to calculate the determinant. Let's go ahead and take that minus 1 element. So it will be 8 into 3 minus 6 minus 5. That's it. Now our job to do the basic arithmetic to calculate the determinant of adjoint M. So now if we do the basic calculation, we find that the determinant of adjoint M is equal to, right, minus 2 plus 6, which is equal to 4. So therefore, we can find that determinant of adjoint M whole square is equal to 4 square, and that is 16. So therefore, it's obvious that option A is not correct. So now we have only two options left, option B and option C. So first we concentrate on option B. Okay, let's go ahead. So here, notice, see, we have to check for the option B now. To check the option B, right, we go ahead and take the matrix equation. M into alpha beta gamma is equal to 1, 2, 3. Put the matrix alpha beta gamma and the matrix M, right? So we get a matrix equation. Now in of these obvious, we have to multiply these two matrix. Now see that the first matrix or the left hand side matrix is of order 3 cross 3 and the next matrix is of order 1 cross 3, right? So the matrix multiplication is valid. Now if we multiply that, right, we take the first row, right? So 0, 1, 2 multiplied by the column alpha beta gamma, we get it as alpha plus beta plus 2 gamma. If we consider the second row and the one single column, we get it as alpha plus 2 beta and 3 gamma. If we consider the third row and the first column, we get it as obviously 3 alpha, 1 beta and 1 gamma. Now if we simplify that, we get a simple 2-column matrix. Now these 2-column matrices are equal, so therefore if we equate element wise, we get 3 different set of equation. Put them as equation number 1, 2, 3. Now our job is to solve that equation. Why? Because our aim is to calculate alpha minus beta plus gamma. To find out that, we need to find out the values of alpha beta gamma, easiest way, or we have to play with that equation 1, 2, 3 so that we can get that expression alpha minus beta plus gamma, which is little time consuming. So we are solving it now. Let's go ahead. So from the equation 2, we are multiplying that equation by 3. So we get the basic simple equation. 3 alpha 6 beta 9 gamma is equal to 6. Put it as equation number 4. Subtract that 3 and 4. If we do so, right, we get it as 3 alpha minus 3 beta, 3 alpha 6 beta minus beta 9 gamma minus gamma is equal to 3. So therefore 5 beta is plus 8 gamma is equal to 3. Put it at equation number 5. Now multiply the equation 1 by 4. If we do so, 4 beta and 8 gamma is equal to 4. Put it as equation number 6. Now here 5 and 6 are the two equations, right, having beta and gamma. So now subtract 5 and 6, straightforward. If we do so, we get it as 5 beta minus 4 beta is equal to minus 3 minus 4 minus 1. That is beta is equal to minus 1. As we obtain the beta, we substitute that in equation. So let's substitute in the equation 1. We get it as, right, 2 gamma is equal to minus 2 and 2 gamma is equal to 1 minus beta, 1 plus 1 is 2 and gamma is equal to 1. So that's it. So beta and gamma is obtained. Now substitute these two in equation number 2 and we obtain the value of alpha. So just simply simple substitution, give that the value of alpha as, right? Here I can see that alpha by simple arithmetic calculation, alpha minus 2 plus 3 equal to 2 and alpha will be equal to 1. So you obtain the value of alpha, beta and gamma. So therefore we can see that alpha minus beta plus gamma is equal to 3, and that's why option B is also the correct option. So here three options A, B, C are already tested. Now only one is left, that is option C. So let's go ahead and test that the remaining option. It may be correct, it may be false. So let's go ahead. So see that here what we are given, it is given that adjoint of m inverse plus adjoint of m inverse, like that is one is inside a bracket and one is that, right, that is equal to m. So that's why we consider that the matrix. Now we know that adjoint of the matrix m inverse is equal to adjoint of m inverse. So now this if we apply that, right, so therefore we can see that, right, the matrix here, right, the will be that adjoint of m inverse, right, it will be adjoint of m inverse and adjoint of m inverse inside the bracket will be equal to, right, the adjoint of m inverse, right. That's it. It's a very complicated thing, but you can understand based on that simple relation, right? If I speak it is little confusing, I understand. Okay, let's proceed that. Now see that in the left hand right hand side both are equal, so we can add it and we can write it as 2 times of adjoint m inverse, right? Let's proceed further. Now see that, right, we know that a inverse is equal to 1 by determinant of a into adjoint of a. Now it is obvious that, right, that we that adjoint of m inverse, then 1 by determinant of adjoint m into adjoint of adjoint m. How we do that? Look carefully. Here I replace the matrix A by adjoint of m. That's the job. Now see that we know that for any square matrix, adjoint of adjoint A is determinant of A whole to the power n minus 2 into the matrix. So therefore this adjoint of adjoint m can be written as determinant of A, so determinant of m whole to the power 3 minus 2, because this matrix are of order 3 cross 3 into the matrix m. So if I go ahead, we write down that matrix. So therefore we again recall one property. It says that determinant of adjoint A is equal to determinant of A whole to the power n minus 1. Here that matrix M is, or adjoint of M is actually the order 3 cross 3. So here we have to substitute n equal to 3. If we go ahead, then we can write it as determinant of M whole to the power 3 minus 1, and hence by normal calculation we can see that it will be M matrix determinant divided by determinant of M. So therefore the required result, or the right hand side, can be reduced to, right, that 2m divided by determinant of M. So we already get it. Now our job is to find out the determinant of M. So if we obtain the determinant of M, our job is done. So let's go ahead and calculate the determinant, the last step of the problem. Let's go ahead. So here we go ahead and calculate the determinant of M by expanding with respect to the first row. So if I expand with respect to the first row by the normal method, right, see that 0, 2 into 1 and minus 3 into 1. Take 1, minus sign, 1 into 1, 3 into 3 with a minus sign. Take 2, it's 1 into 1 and 2 into 3. That's it. So that's the job, right? Now let's go ahead, right? If we do the simple arithmetic calculation, right, we can calculate the determinant of M is minus 2. So therefore, if I substitute in that determinant of M is minus 2, we calculate it as minus M, and hence we can say that option C is also correct. So therefore, for this particular problem, we have 3 options and 3 options are correct, that is B, C and D, and A is the only false option, right? That's it. Hope you understood the problem. Thank you.